All right, I'm back for module 2 here for our final study guide. I got some coffee. Yeah, very happy black. Always drink your coffee black. That way you don't get in front of people in the line and you develop a nice palate for strong, delicious flavors. All right, so we're gonna, it kind of got cut off by the punching machine, but it says solve for x for one-step equation. So we got 4x equals 200. And this is something I still see people mess up on. Like, what is this 4 doing to this x? Well, there's secretly like a little multiplication sign there. We don't write the multiplication sign because we don't have to. We just assume that 4 and an x next to each other means 4 times x. So if 4 is being multiplied by x, to undo that to get x by itself, we have to, in fact, divide both sides of the equation by 4. This is the division property of equations. If we divide, we have to divide both sides. So 4 divided by 4 cancels out, becomes 1, right? 4 divided by 4 is 1. And so we're left with 1 times x, and of course we don't write 1 times x because we can write 1 times anything. So we just simplify this as x equals whatever 200 divided by 4 is, and that's in fact 50. And so that's all we need to do. I see people, even on the quiz we took 3 days ago, trying to subtract 4 away and having x equal 196 or something like that. Like, that doesn't make any sense because this x still counts. That x is still there. All right, next. Discrete and continuous relationships. Identify whether the following statement represents a discrete or continuous relationship. The Great Depression, stock markets fell 75%. So you got to think about what the stock market is. Okay, the stock market rises and falls all the time. The Great Depression was an event. The Great Depression didn't happen in a single day. Prices didn't go from 100% to 25% in an instant, the way that a piggy bank would. Over time, it started here, and then it went down and down and down and down and down. Right? You've seen these sort of like lines before, to the point where it has fallen 75%. This is going to be continuous, so be careful of that. Let's move on up. All right, building block: comparing rates of change in linear and exponential situations. So state whether the situation has the greater, or which situation has the greater rate of change. Riding a bike 10 miles an hour or jogging 3 miles in 24 minutes. So we have a problem with our units. We're comparing hours to minutes. 24 minutes is not more than 1 hour. So let's actually, the first thing I'm going to do is I'm going to turn this to 10 miles in 60 minutes so that I'm comparing miles to miles, 3 to 10, and minutes to minutes. Well, miles, minutes, minutes. See, I was writing M, and that didn't make sense because I had miles and minutes. That wasn't a good way to do it. So this is my comparison. And remember, when you get in the car and you look at the odometer, it says miles per hour, right? You see that slash? That's a division sign, okay? That's what miles per hour mean. The P is a division sign. So we have 10 over 60. This represents the bike. And then we have 3 over 24. This represents the jogging, okay? And so all we have to do is compare what these fractions are. So this becomes 1/6, and this becomes 1/8, okay? So which one is the bigger fraction? That will be the fastest situation. Well, 1/6 is greater than an eighth, right? If I gave you, a pie, do you want a sixth of it or an eighth of it? Right? You'd want a 6, it's more pi. Unless you don't want pi, then I guess you'd want 1/8. But we're trying to get somewhere here. That's not the point. We're trying to get somewhere here. And so 1/6 is going to be greater than an eighth. So we know that this is actually a faster rate of change. The biker is moving faster than the jogger. Next, building blocks. Comparing linear and arithmetic and exponential geometric models. So it wants us to find the difference here. And so, again, what we're going to be doing is building a little equation. So for the arithmetic, I see to get from here to here, I'm adding the difference. To get from here to here, I'm adding a difference. I'm adding a difference. And I'm adding a difference. So to make this work, what I'm actually doing is I'm taking my first value, -12. I'm adding 1, 2, 3, 4 differences. and that's going to equal a negative 0.75. And so now all I have to do is solve for d. So let me grab my calculator here. So I have to add 12 to both sides to get this to cancel. That becomes 0, so I have 4d equals let me see if I can get this so we can see it, negative 0.75 plus 12, give me 11.25. And now I want to get d by itself, so I'm going to divide by the number multiplying by it, 4, divide by 4, divide by 4. All right, so that ends up giving me 2.8125 as my common difference. So if I take my initial value, negative 12, and I add 2.8125, I end up with negative 9.1875. If I do it again, add 2.8125, I get negative 6.375. If I do it again, add 2.8125, I get negative 3.5625, and then if I do it again, if I add 2.8125, I should get negative 0.75. Sure enough, I do. I have done it correctly. I feel good about myself. All right, so that's arithmetic. Now I need to do it for the geometric. For geometric, something else is happening. I'm not adding d at each step. Instead, what I'm doing is I'm multiplying by a ratio. So this is going to be times my common ratio, times my common ratio, times my common ratio, and then times my common ratio. So what I end up with here is I get negative 12 times the ratio once, twice, 3, 4 times, so to the 4th power. And that's going to equal negative 0.75. Okay, so now I need to get this by itself, so I need to get the r term alone, so I'm going to divide by negative 12, divide by negative 12. Okay, so clear this out. I get negative 0.75 divided by a negative 12, and that's going to give me r to the 4th equals 0.0625. And so now I need to take the 4th root of this, the 4th root. So to do that, I have to use this function here. I have to hit 4 second x root, and you can see it pops it up as the 4th root. And then the answer, I just hit second answer so that I didn't have to type it all in. You could have typed in 0.0625, it would have been the same thing. And that tells me that it's a half. So r equals 1/2, or 0.5, depending on how you want to think about it. So knowing that, I know that I'm just taking half. Half of negative 12 is negative 6. Half of negative 6 is negative 3. Half of negative 3 is negative 1.5. And half of negative 1.5 will be negative 0.75. Building equations, one step at a time. All right. Next problem. It wants us to prove that the two equations are equivalent, and it wants us to do that by simplifying the equations on the right side of the equation. So all that we're going to be changing is the right side. So we should leave x minus 5 alone on the left side. We don't touch it. We're just looking at 5x minus 7 plus 2 times the quantity, 3x plus 1 minus 10. X. All right. Parentheses. Can't combine those. They're different terms. Multiplication. This 2 is multiplying here, so it goes there. So we get 5x minus 7 plus 2 times 3x is 6x. 2 times 1 is 2, and then minus 10x. No multiplication, no division, so now we're going to add. So we're going to combine our like terms. I'm going to start with my x terms. I have a 5x, a 6x, and a negative 10x. So 5 plus 6 is 11. 11 minus 10 is 1. So that's x. Now I have my constant terms. Negative 7 plus 2. Negative 7 plus 2 is negative 5. So does x minus 5 equal x minus 5? Yes, it does.
Good morning.
I'm recording a video right now, so please keep it down. Thank you. Next, we're going to the next building block, which is lines and graphs. So make a graph with a function based on the following information. Add your axes, choose the appropriate scale, and label your graph. Then write the equation of the function. So if the beginning value is negative 8, and its value is 2 units larger at each stage, okay? So the beginning value, so that means at 0, the value is negative 8, right? When x is 0, our y is negative 8. And then it's 2 units larger at each stage. So at stage 1, it'll be negative 6. At stage 2, it'll be negative 4, et cetera, et cetera. So pretty much when I see this, I can kind of see the equation, right? You know, if y equals mx plus b, well, my common difference is 2, so y equals 2x. And then what's my intercept? Well, it's not plus anything, it's minus 8. So pretty much this is the line I have to graph. So whether you view it as a table in a series of points or as a line, we can graph it from there. So I'm actually, since I need it to be at negative 8 at some point, I'm actually going to do something like this. Shoop. Shoop. 1, 2, 3, 4, 5, 6, 7, 8. So there's negative 8. And it's going up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So that is my line. Kind of neat. All right. So we'll go ahead and take a pause there. I'll come back and I'll do module 3 in a different video.